In layer 2, we see MAC address. MAC address is used in layer 2 to identify a device. Devices that are in same network. To communicate, a switch is what needed, not the router. What does it mean? We got computers, or you may be having even a router, or a server, or a firewall. If they're all in same network, like 10.0.0.1, 2, now to communicate between these computers and servers and firewall and the router, because they're all in same subnet, you need only a switch. Why? Because they're all in same network, there is no routing needed. There is no route here. You don't need to keep a router. Just the L2 device, layer 2 device is enough. Why? Because they're not having multiple networks. Those devices, they all have same thing. So moving the packet from one device to another device will be only based on the MAC address. There is no necessary for moving packet from one network to another network, so there is no need for a router. That doesn't mean that you don't need an IP address. That is different story. You still need an IP address to identify a device. But the router is not needed because you are not going to communicate from one layer 3 to another layer 3 domain, one network to another network. We are not communicating between one network to another network. In that sense, it is only a layer 2 communication. Some people misunderstand this term. When we say layer 2 communication, they say only the MAC address is needed for communicating. No, IP address is also needed. Only by using the IP address you can ping. Have you seen anyone ping with MAC address?
No, sir.
We ping with IP address. We send the traffic to the IP address, not the MAC address. We use only the IP address, but MAC address will be used behind the screen. ARP will be learning the MAC address of that IP address to which you want to go and puts that as a destination MAC address. When the packet goes here to the switch only will read the layer 2 header, see the destination MAC address and deliver the packet to the destination. For example, if I have MAC address on this device as A, B, when I have these MAC addresses on these devices, so we are not going to use any of this MAC address to deliver a packet. We only use the IP address, but behind the screen, they use the MAC address of the destination that you want to send the traffic to. And for example, if let me name these computers E, D, C. If C wants to talk to E, what does it mean? You may be pinging 10005. That's what C trying to talk to E. So this is your packet, and to your packet, what happens is the source address 10003, the destination address 10005 is given in layer 3. See, it is in same network 10 and 10. So there is no need for a router for this communication to happen. Now what happens is this C device sends an ARP request because it don't know anything about 10005. You pinged, that is what it knows. C knows about E only at the IP address of E. C has got no idea about what E is, what MAC address the E has got, nothing. So the MAC address field will be empty. Without MAC address, you cannot send any packet. That is where ARP comes. What ARP will do, ARP will send a broadcast asking, hey, who is the 10005? Tell me, who is it? And D will not respond, A will not respond, B will not respond, but E will respond saying, hey, it's me 10005. How may I help you? See, this is what me. When it says me, the MAC address is coming in the ARP reply. From the ARP reply, device C learned that 10005 MAC address is EEE. So now it puts that EEE and pushes this packet to the switchboard. Switchboard knows where is EEE because the ARP request reply and all coming, no? So switch has already learned. I told you in the previous class, they listen to the port, they learn the MAC address. Do you remember?
Yes, sir.
So switch knows where is EEE. Now it is going to send the packet only this way, not to any other device. So it is only the MAC address that is involved in moving the packet, but where to move is depend on the IP address. So if someone is simply imagining themselves saying only the MAC address is involved, no IP address is needed for this communication, they are not giving complete answer. Only MAC address is needed for moving the packet, I agree, but where to move is decided based on IP address. Whether it is a layer 2 communication or layer 3 communication, both IP address and MAC address are always needed. Okay, next. Now we are getting into another important portion of switching called VLANs, Virtual Local Area Network. What is VLAN? Virtual Local Area Network. Virtual Local Area Network. Now this Virtual Local Area Network means virtual switch. Means broadcast domain. So VLAN is Virtual Local Area Network. VLAN is breaking down a large broadcast domain into multiple small broadcast domain. Multiple small broadcast domain. VLAN, virtual local area network. It is creating multiple switches, multiple virtual switches. Each virtual switch is a broadcast domain. So if you have multiple small broadcast domain, because you can create multiple virtual switches. Creating multiple virtual switches in a physical switch is what called as VLAN. You see, you got a physical switch. Let us say you got 48 ports in this switch. By default, all the 48 ports, by default, all these 48 ports form one VLAN by default. All these 48 port will be in one group. All these 48 port will be in one broadcast domain. All will be in single broadcast domain. Hope you understand what is broadcast domain. They're all in one group. Any packet sent to one of this port will go to all the ports if it is a broadcast packet. If you send any broadcast packet to one of this port, it will go to all 48 port because they are all in same group. Because it's a broadcast packet, it will go to every member of the group. Did you understand single broadcast domain?
Yes, sir.
By default, switches will have all the ports under a single broadcast domain. So, all ports in single broadcast domain forms one virtual switch. Even though it's a physical switch, inside logically it is one virtual switch identified with a number called 1. We call it as default VLAN. We call this as default VLAN. The VLAN which you cannot create, you cannot delete. This VLAN you cannot create, you cannot delete. It is there by default. And every port will be member of this VLAN. All 48 port. Port number 1 to 48. Now, we can create multiple VLANs and form multiple switches. Physically it is one switch. What I can do is I can create virtual switch. I can create this as one switch and this as another switch and this as another switch, and I can also create This is another switch. Physically one switch, but how many virtual switches I got? 4.
4.
Now, if I send any broadcast to this port, it will only disturb this one, and this one port. No other ports will be disturbed because this forms one broadcast domain. This is what VLAN. How many VLANs I have? Red VLAN, green VLAN, brown VLAN, purple VLAN. 4 VLANs. But red, brown, green, purple is not the word used for identifying VLAN. We use number. For example, brown, VLAN number 20. Purple, VLAN number 30. Green, VLAN number 40. Red, VLAN number 10. So like this, you can assign numbers to identify this broadcast domain. We don't color, we number. VLANs are identified by
By the
number.
number.
How many bits are reserved for VLAN? 12 bits are reserved. As a result, you can have VLAN number starting from 1, which is default VLAN, you cannot create. So configurable VLAN is starting from 2 to 4096. This is the biggest number in VLAN you can give. 4096. Even inside this 4096, some VLANs are reserved, which you cannot use. So this is the biggest number to identify a VLAN, 4096. The smallest number that you can give to create VLAN is 2. The number VLAN 1 is default VLAN. You cannot configure because it is already configured. You cannot delete because it is default. You cannot even change the name. The name of VLAN 1 is always default. Now, VLANs helps us to create multiple virtual switches. Each VLAN is a virtual switch. Each VLAN is having their own broadcast domain, means their own group. So how can you define a VLAN? If someone is asking what is VLAN, what you are going to say? VLAN is grouping of ports to form a broadcast domain. VLAN is creating multiple virtual switches inside a physical switch. VLAN is breaking down the large broadcast domain into small broadcast domain. What does that mean? Before creating VLANs, all the ports were member of one big large broadcast domain called VLAN 1. All 48 ports were member of that VLAN 1. But now by creating VLANs, we have broken down the big broadcast domain into small broadcast domains. Earlier, one broadcast domain and 48 port, but now you have four broadcast domain. In one of the broadcast domain, you have only 5 port. In another, we have only 2 ports. So, broadcast domains, we get many by creating VLAN. What is the advantage? Advantage is we get different groups of layer 2. If all are in same layer 2, if all are in single layer 2 group, then broadcast in one port will impact all 48 members. If one port is sending broadcast, another 47 devices will get disturbed, which will decrease the performance. Which will decrease the performance of the switch. Whereas when you send a broadcast to a VLAN called 10 here, only the four other computers gets the broadcast. Others are not experiencing the broadcast. As a result, you improve the performance. See, we have grouped these 5 computers because they are the one they are going to talk. They all belong to same department. When a broadcast is sent from this computer here, this computer, it is not necessary to disturb the other departments, not necessary. So what we do, we put them in different department and different VLANs so that the broadcast of one department will not disturb other department. So definitely it improves the performance. It improves the bandwidth. How? We don't simply broadcast to everyone and waste their bandwidth. So VLANs improves the bandwidth, VLAN improves the performance. Not only that, VLAN also provides security. How? A member of VLAN 10 cannot talk to VLAN 20. Cannot. Because they belong to different group. They belong to different broadcast domain. Then you may ask, like, what if someone from the sales department want to talk to HR department? Yeah, they can talk, but not through the switch. They have to go out from the switch to a router, and router will bring the traffic. Say, for example, let's say there is one port here connected to, because I put red color, you should not think that I'm, okay, this port. There is one common port called trunk port, which will carry all VLAN traffic. And there is a router here. Router only will be allowing traffic from one broadcast domain to another broadcast domain. See, here each VLAN will be in different network layers, say 10 network, 40 network, 30 network, 20 network. Now, communicating between the networks, you need router, right? Yes. So, different VLAN, different network. Different VLAN, different network. So, if someone from here, 10001, wants to talk to someone here, 40001, if they want to talk to 40001, first they have to go out to this router, and router will route it back on this, like this. Without router, members of two different VLAN cannot communicate. So in the router, if you want to allow, you can write a permit statement. If you want to deny, you can put a deny statement. So you put all those policies in the router. If you don't like sales department talking to HR, put the ACL in the router. That's why we learned ACL. So VLAN provides security. Did you understand that?
Yes, sir. Sir,
Each
what is plan port?
I'm coming there.
Okay, sir.
So VLAN provides security. VLAN provides isolation from one department to other. Now we learned what is VLAN. Let us say we got many switches. Right now we just took one switch. Let's say you got many switches. Okay. Right? Let's say many switches, but I'm just drawing two switches. And you got VLANs. Fine. Here for purple, 6 ports are there. Here for purple, only 2 ports. It doesn't matter. You can have different alignments. That doesn't matter. But you got some VLANs in common in both the switches. As I said, VLAN purple means what? VLAN purple number is VLAN 30. So you got VLAN 30 here, and VLAN green is 40, VLAN 40, VLAN 10. VLAN 10, oh no, yeah, right, VLAN 40, and this purple is VLAN 30. And you also have VLAN 20. So there are some computers connected to VLAN 10, 40, 30, 20 on the first switch, and some are connected to 10, 40, 30 on the second switch. Now, let us say VLAN 10 is for manager. And VLAN 40 is for project 1 members. In the company there is a project called project 1. For those project 1 members, you got VLAN 40. Likewise, you have given different VLANs to different projects. Now, you see the project 1 member. He is a member of, he is connected to switch 1. Maybe this is the ground floor. And this is the first floor. The first floor, there are some project 1 people sitting. Let's say Kiran is sitting in ground floor. He's one of the employee who is working in project 1. And there is another person called Ram in the first floor working in the same project. Kiran and Ram, they work for same company, same project, but they are not connected to the same switch. They are connected to different switch because they are in different floor. And there is one manager, project manager called Job, and there is another project manager called Jack. But they are not sitting in the same floor, they are sitting in different floors, so they are connected to different switch. Now if Jack and Job want to talk, if Kiran and Ram want to talk, what is needed? You need to take one connection, green connection, and you need to connect it here in same VLAN. And then you need to take a black connection, sorry, a red connection from the red port you need to connect, which is not practically possible. For each department, you cannot have a separate wire just for interconnecting. So we will take one of the port in the switch. I said it's a 48 port switch. Let's say this port is left. This is not in use. We can take this port and there is another port here free. I can connect a wire and I will configure these port as trunk port. What is a trunk port? The port that can send and receive all VLAN, multiple VLAN traffic. The port that can send traffic from Job as well as from Kiran, so that Job can talk to Jack. Job cannot talk to Job cannot talk to Ram, because Ram and Job are not same VLAN, but Jack and Job is same VLAN. Jack can talk to Job and Job can talk to Jack. Likewise, Ram can talk to Kiran and Kiran can talk to Ram. Using this one single link, this link can carry now VLAN 10 traffic. What is VLAN 10 traffic? Communication between Jack and Job. What is VLAN 40 traffic? Traffic between Kiran and Ram. This one single link can carry both, not only both, all VLAN traffic. If you have someone in 30 also, let's say in 30, there is someone called Andrea. In switch 1. In 30, in switch 2, there is someone called Alumelu. Both Andrea and Alumelu can talk using the same black line called trunk link. What is a trunk link? The trunk link is just another wire, same like what you connect to VLAN 1020, but they are connected to a trunk port. Because they are connected to trunk port, they are called as trunk links. Trunk links can carry multiple VLAN traffic. You understood?
Yes, sir.
Right. Now, we got trunk link, we got trunk port understanding. Now, what about these ports? These ports are not called as trunk ports because they don't carry multiple VLAN traffic. This port, this port where Jack is connected, they are not trunk port. Why? They cannot carry multiple VLAN. They belong to VLAN 10 only. So those ports that belong to a single VLAN, is called as access port. Access port. So in a switch, you will find access port by default. By default, all ports will be access port. So now if you are connecting to another switch and extending the VLAN, like what you have here, like VLAN 10, you are extending to switch 2, VLAN 40, you are extending to switch 1 and switch 2, they are extending. If you're extending VLANs, then you can extend it using trunk port. When you have a trunk wire, don't think it is simply connecting between these two switches. No. If Job is sending traffic, the traffic will be going with a VLAN number. What is the VLAN number of Job 10? It will go with the VLAN number, and when it hits this port on the second switch will read this number and send it only to that red boundary, only to this red broadcast domain. It won't send it to where the RAM is. It will send it only to this VLAN 10 member where Jack is, because the receiving switch can see that it is coming from VLAN 10, because Job is in VLAN 10. When Job generates a traffic, the trunk port will, the switch 1 trunk port will mark it, saying this packet belongs to VLAN 10. Now this marking helps the receiving switch to understand to which VLAN this traffic belongs to. Is this clear? That's the job of a trunk port. It will mark the VLAN and send. On the receiving switch, it will read the VLAN number, and then it will send the packet. By removing the VLAN, it will send the packet to the correct VLAN members on the receiving side. Is that clear?
Yes, sir.
Okay. So we learned about access port, we learned about trunk port, we learned what is VLAN, and next, this is VLAN. Now let us do a small lab. Are you ready for the lab?
Yes, sir.
I'll take two switches. One, two, and we will take one to a computer. We'll also take one, two. Let me name this as 10001. This is, see, every VLAN should be in different network, but for your learning purpose, I'm giving same 10. Why I'm doing this? No, these two computers will not be in same VLAN. If they are not in same VLAN, even though they belong to same network, they cannot ping. You understand?
Yes, sir.
These two computers, if I put in two different VLAN, they will not communicate, because they belong to two different group. So you can easily understand, yeah, VLAN is not allowing. If I put different network, you will not know that. So here I'm going to say 10002. Here I'm going to say 10051. Initially, no VLANs will create. Please understand, I'm just connecting the wire. Right. You see that names of the interface? Tell me, will they ping each other if I don't configure VLANs? If I'll just simply configure IP address, will they all ping? Yes, they will ping. See, there is no need of gateway because we don't have a router. All right. Now you see, I told you by default, show VLAN brief. You see, by default, all the interfaces belong to which VLAN?
One.
What is the name?
It's default.
Default. Let us try to change the name. VLAN 1 name some name we can say unused. See, it's not allowing. Why? Default VLAN 1 may not have its name changed. You understand? You cannot even
Yes, sir.
change the name. Okay. So default VLAN is VLAN 1. Let me name this as switch 1. Show VLAN brief. So as a result, what I'm trying to make you understand here is, right now I can ping from A to B to C to D. You know why? Because including this port, all the ports are in same VLAN. You see? Even in this switch, if you see, second switch, need to wait some time. So what I'm saying is, here also all belong to VLAN 1. In that switch also all port belong to VLAN 1. So they form one broadcast domain. Understand this very well. If you don't have VLANs, when I connect switches like this, all the ports of these switches belong to what VLAN now? Only one VLAN called VLAN 1. Agree?
Yes, sir.
So what will happen if in office someone send a broadcast packet? It will go and disturb everyone because they are all in same broadcast domain, which is very dangerous.
Yes, sir.
That's why you need VLANs. Now we have two switches, but both the switches are in same broadcast domain now. As a result, when I ping from this computer, I can ping anyone. Ping the very next computer 10.0.0.50, I can ping. I can ping 10.0.0.2, which is in the next switch. I can also ping 10.0.0.51, which is also in the next switch. I'm able to ping anyone because all are in same broadcast domain. But assume that this belongs to department 2. And these two belong to department 1. Now, you do not want department 1 broadcast to go to department 2, or you do not want department 1 and department 2 to communicate. That's why you want to put them in different VLANs. You understand?
Yes, sir.
I'm going to do that. Listen carefully. Are you watching?
Yes, sir.
You see. Department 1, I'm going to put it in VLAN 10. Department 2, I'll put it in VLAN 20. You may have many computers in Department 1, and all you have to put it in VLAN 10. Repeating again, you may have many computers in VLAN 1.
On depot.
And you need to put all of them in. Okay, instead of talking, I'll do and show you. Say I have another computer. This also belongs to Department 1. So interface 1 and interface 4. See, currently the interface name is interface 4. Interface 1 and 4, I want to put it in VLAN 10. You understand?
Yes, sir.
So now let us do that. How to do it? See, VLAN 10. First you create VLAN. This is how we create VLAN. Which mode I am in?
Global.
Global configuration mode. I mean go global configuration mode. Now, you can optionally name Department 1. Then, what is next? You can verify this. Show VLAN brief. You see? You see that? New department VLAN created. But there is no interface assigned.
Yes, sir.
What you are going to do is, you are going to take 01 and 04 and put it in that VLAN. 01 and 04.
04.
How do we do that? You see, use this command. Interface range. You see, use the word range only if you have many interface. If you have only one interface, don't put range. You got it?
Yes, sir. Yes, sir.
What are the interface? F0/1, comma, F0/4. You understand?
Yes, sir.
So you are inside both the interface now. You got it?
Yes, sir.
And I said, if a port belongs to a VLAN, it is a access port, not a trunk port, correct?
Yes, sir.
So we need to say switch port mode access. Switch port mode access. Switch port mode access. Next, what you need to say? You need to say to which VLAN they will access. What is the VLAN that you created?
VLAN 10.
Okay, this is the command. Switch port access VLAN 10. Yeah? This is how we allocate, we assign interface. Let's go and verify. Have you copied this?
Wait a minute. Yes, sir.
Now you see, show VLAN brief.
Sir, if we have 10 interfaces, what should be the range?
Same command. See, if you have 10 interface, if it is continuous number, then you need to just
Yes,
put
sir.
10 like this.
Oh, okay, sir.
Write down. If it is continuous, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you put like this. If it is not continuous, then you need to put comma. Like I said, no? You need to put comma.
Yes, sir. Okay, sir.
Next. So there is another interface F02. Interface F0/2. See, I'm not using range command. Which VLAN I need to put that? VLAN?
Department 2.
Well, what is the VLAN I
VLAN 20.
told? 20. So, switchboard mode access. Okay, before that, did you see this one?
Yes, sir.
See, from here, interface 1 is missing, interface 4 is missing. Because we have taken it from default VLAN and we have assigned it to VLAN 10.
VLAN 10.
Likewise, we are going to assign interface 2 to VLAN, interface 2 to interface F02. The command is switchboard access VLAN 20. You see, I did not create VLAN 20, did I? Did I create
No,
VLAN 20?
No, sir.
No. It says the VLAN that you are telling does not exist, but creating. So what I am coming to say is, like you created for VLAN 10. See, for VLAN 10 we created like this. If you fail to create, it is okay. When you assign a VLAN number which you have not created to an interface, the VLAN will get created automatically. You understand?
Yes, sir.
But the VLAN name will be some random name it will give. For VLAN 10, I gave name what?
Department 1.
But for VLAN 20, because I did not create, it dynamically created. Now you see, show VLAN brief. It has given some random name. And interface F02 is in VLAN 20. Now these two will not ping each other. These two computer will ping. These two are in same VLAN. I think we have to give IP address to this computer. 10.0.0.3. 10.0.0.1 and 10.0.0.3 will ping. You see, 10.0.0.3 will ping because they belong to same VLAN. They will ping. Oh no, I think I didn't put IP address inside here.
Yes, sir.
10.0.0.3. Now from here, if you see, you can ping 10.0.0.1 because they belong to same VLAN. But 10.0.0.50 you cannot ping. Reason is different VLAN.
So can we ping from 50?
How you can ping?
Sorry, 51.
51 to where?
03.
How you will ping? 51 is in which VLAN? The default VLAN 1. Hello.
Yes, sir.
We have not configured this in any. This is in VLAN 1. No, the switch is in VLAN 1. All the interface right now in VLAN 1. You see?
Yes, yes, yes.
Show VLAN brief. Correct? We have not created VLAN 10 and 20 here.
Yes, sir. Yes.
So, even this you cannot ping. Even though this belongs to department 1, you cannot ping this. Why? From this computer, you can ping 3. Department 1 is also in 3. But you cannot ping 2. Why?
It VLAN 1 by default.
This is in VLAN number 1 by default. It is not still in VLAN. It is not assigned to VLAN what?
10.
That's the reason. You know the reason.
So what if we have 3 switches or multiple switches?
And you need to go and configure VLAN 10 in all switches wherever you want to ping it.
Okay, sir.
Now, let us go and configure VLAN 10 here. Interface, what is the interface name for VLAN 10? F02. Correct?
2. Yes, sir.
Interface F0/2. switch port mode access, switch port access VLAN 10. See, I'm not creating VLAN, it gets created automatically. Likewise,
Yes, sir.
interface F0/3. What is F0/3? VLAN 20, department 2.
Yes,
Switch
sir.
port mode access VLAN 20. Now, show VLAN brief. You see, 02 is in VLAN 10. 03 is in
03 is in
VLAN
VLAN
20. See, 2 and 3
20.
is missing here. Yeah?
Yes, sir. Yes, sir.
Now, what is next? Likewise, in this switch, 1 and 4 is in VLAN 10, 2 is in VLAN 20. So this is in
20.
VLAN 20, this is also in VLAN 20, right?
Yes, sir. Yes, sir.
Both are in VLAN 20. But will they ping? They won't ping. Why? Because you have not configured trunk here. This port is not
Yes,
trunking.
sir.
You go and check on this. There is a command called show interface trunk. There is no interface trunking. You see, it is blank. You got it?
Yes, sir.
There is no interface trunking now. So let us now go to interface F0/3 and say switch port mode. Instead of access, you are going to say trunk. Copy down.
Okay, sir.
Now we have to configure trunk on the other side. Let's go to the other side and configure trunk. Interface F. What is the other side interface name? Which one you want to make it as trunk in switch 2?
01.
Interface F0/1 switch port mode trunk. Okay, now if you see, you can go to any switch and try this command, show interface trunk. You see, it is saying I am trunking. I'll allow
Yes, sir.
all the VLANs to go, but currently these are the VLANs configured, correct? VLAN 1 is default,
Yes, sir.
10 and 20 is what it says I'm allowing these VLANs via this port. Likewise, on the other side also it should say show VLAN brief. VLAN 10 and 20, show interface trunk. You see, this is also saying I'm allowing the VLANs 10 and 20. It is matching on both sides. Understood? Now,
Yes, sir.
let's get ready for the testing. See, from 10.3, if I ping 10.2, 10.2 is in same switch or different switch?
Different switch.
It will ping, you see, because trunk is there.
Yes, sir.
Now, from this department 2 computer, if you ping 10.00.51, which is in different VLAN, I'll be able to ping. Listen, did you see that? It is
Yes, sir.
pinging.
Yes, sir.
Because the link in between two switches is a trunk port.
Yes, sir.
It is carrying traffic from here to here. It is also taking traffic from here to here. Is it clear?
Yes, sir.
Yes or no? Did you understand?
Yes, sir. Yes, sir.
The purpose of trunk.
Yes, sir.
It can carry multiple VLAN. But these two cannot ping each other. Even though they are very next computers, they cannot ping each other. You see? 10.0.0.1, it won't ping. Because they are separated by different broadcast domain. They are in different VLAN. Even though they are in
VLAN.
same physical switch, they are logically in different switches.
Yes, sir.
You understood today's class?
Yes, sir.
Tomorrow we are going to do STP, spanning tree protocol.
Protocol.